Hello, in this video we're going to look at maximizing social welfare. Jeremy Bentham, a utilitarian, argued the social welfare function, the sum of each person's utility function in society, should be maximized. So here's an example of the social welfare function according to Bentham. Welfare, or social welfare, equals person 1's utility plus person 2's utility plus person 3's utility, and so on. So here we have a problem. We're going to have two people with the following utility functions for good X. Here is person 1's utility function and person 2's. Let's assume there are 140 units available for consumption. So 140 equals person 1's consumption plus person 2's consumption. And our goal here is to find the allocation of good X between these two consumers that maximizes W. So how should X be allocated between the two people to maximize social welfare? So we're going to do a Lagrangian. So I set up a Lagrangian here, L, and I have person 1's utility plus person 2's utility function, and then it's going to be subject to the constraint that there are only 140 units available for consumption between these two people. So we're going to take a partial derivative of the Lagrangian with respect to X subscript 1. So I bring down this 1/2 in front, so that's going to leave us 1/2 times 20, or 10, and then 1/2 minus 1 means X here is going to be raised to the minus 1/2 power, and we got lambda being multiplied by minus X subscript 1, that's just minus lambda. We're maximizing, set the result equal to 0. And all I'll do here next is I'm just going to move this lambda over to the right hand side and solve this expression for lambda. So we get this. Let's do another partial derivative, the partial derivative of the Lagrangian with respect to X subscript 2. So the partial derivative of 2X subscript 2 is just 2, and this lambda is being multiplied by minus X subscript 2, and that's just minus lambda. Solving that expression for lambda, lambda equals 2. And then one final partial derivative here, we'll get back the constraint. The next thing I'll do is I'll set lambda equal to lambda, these two lambda expressions, set them equal to one another, and then solve. So dividing through by 2. Following the rules of exponents, moving this x term down into the denominator. Multiplying both sides through then by x to the 1/2 power. Gives us this result. And then squaring both sides. Person 1 will get 25 units of good X, and person 2, since there are 140 units available, 140 minus 25, person 2 will get 115 units available. So that allocation will maximize social welfare. All right, that's it. I hope you found this video helpful.